Okay, so in the last class, we were talking about how to solve for equilibrium concentrations when we're not at equilibrium. And then we're going to set up ice tables. So let's review the first problem we did. So we have hydrogen gas reacting with fluorine gas to make this hydrogen chloride gas. Now, in this problem, we need to start with our initial concentrations. And we had 2 moles, 2 molarity of each. Remember, we're going to put concentrations in these ice tables. And then an ice table stands for the initial concentration, the change in concentration, and the equilibrium concentration. So since we have initial concentrations of each species in this equilibrium, we need to figure out where we're at. So that's Q. So for this problem, we're going to solve for concentration of products, so HCl squared, because it's 2HCl, over the concentration of H2 times the concentration of F2. And we end up with 2 squared over 2 times 2, so Q is 1. Now in this problem, Q is 1, and it told us that K was 115, so I would say Q is significantly less than K. So this means this equilibrium is going to shift to the right. Okay, now if this equilibrium is going to shift to the right, it means that the concentration of products will go up, so this is going to be 2x, and the concentration of the reactants is going to go down. So minus x each. Now again, why is this 2x? Because we have this mole ratio of 2 here. So now our equilibrium concentrations will be 2 minus x, and this would be 2 plus 2x. Okay, now to solve for k, k is going to equal concentrations of products times reactants, and the product is 2 plus 2x squared. Again, because we have 2 in there. And then it's the reactants times each other. So we have 2 minus x times 2 minus x. So for this problem, I think we have to be able to envision algebraically that 2 minus x times 2 minus x is 2 minus x squared. Okay, now we know that k was 115. So now we could square all of this. So we get 2 plus x divided by 2 minus x equal to 10.7. We solve for x, and x is equal to about 1.5. And then we have to plug this back into the equilibrium concentration. So if 2 minus 1.5 and 2 minus 1.5 means the concentration of H2 and F2 are going to equal about 0.5 molar each. And then for HCl, 2 times 1.5 plus 2 is about 5. So the concentration of HCl at the end will be about 5 molar. Okay, for the second problem. In this one, we have chlorine gas turning into 2 chlorine atoms, and told us our K again. Now, since it said it didn't give us any information about chlorine, we'd have to assume that's 0. So since we don't have anything for the chlorine atoms, this equation would have to shift to the right to reach any sort of equilibrium. We can't have a 0 in there. So I would say that this one is going to be plus 2x, and this one is going to be minus x. Again, that's because we have a 1 to 2 ratio here. So the equilibrium concentration of the chlorine molecule will be 2 minus x, and then 0 plus 2x is 2x. So K would equal 2x squared. Now we need to make sure that this stays in parentheses. And on the bottom, we got to have 2 minus x. Now for this problem, when you can't just complete the square, I'm not going to make you use the quadratic equation in class. So this time around, we're going to do a special trick. We are going to get rid of this minus x here and say it's insignificant. It's negligible compared to the 2 value. So if you feel like you cannot square everything, you're going to do this little cross out of minus x. Okay, so now K was 1.13 times 10 to the negative 4. That's going to equal 2x squared, which is 4x squared. We need to remember that 2x was in parentheses still. So equals 4x squared, and 4x squared divided by just 2. Okay, now we can just do some algebra. We solve for x. X is equal to 0.008. And then we plug that in here. We find out the equilibrium concentration of Cl2 would be 2 minus 0.008, so 1.008 0.992. And then the equilibrium concentration of chlorine would be 2 times 0.008, so 0.016. And these would both be an ATM. Okay, the last problem. So we have carbon monoxide plus water form carbon dioxide and H2. The K is 5.1. It tells us that all of these are at 0.5 molar. Since it gave us initial concentrations of everything, we need to solve for Q to find out what's going to happen. So Q is going to equal the CO2 concentration times the concentration of H2 divided by the concentration of carbon monoxide times the concentration of that water or the steam. Now, since all these values are the same, we're going to have 0.5 times 0.5 divided by 0.5 times 0.5. Q is going to equal 1 again. And 1 is less than K, which is 5.1. When Q is less than K, the equilibrium shifts to the right. So we're going to have plus, this is a 1 mole ratio, plus X. The reactant concentrations would go down, so minus X minus X. Now this means that the equilibrium concentrations would be 0.5 minus X, 0.5 minus X, 0.5 plus X, 0.5 plus X. Okay, now we need to use these equilibrium concentrations to solve for X. So K was equal to 5.1. So 5.1 equals the concentrations of the products divided by the concentrations of the reactants. Now again, we're either going to be able to get rid of the X on the denominator, or we're going to be able to take the square root of everything. Now, algebraically, we need to be able to identify that for this problem, 0.5 plus X times 0.5 plus X is 0.5 plus X squared, divided by 0.5 minus X times 0.5 minus X is 0.5 minus X squared. Okay, we can now take the square root of this entire algebraic expression. We solve for X, and then we plug that X back into these equilibrium concentrations to solve for them. So this is the last problem. I'm not going to do the last part for you, but I did get you set up here. Okay, I hope that helps.